All right, let's get started with 6.4b, continuing logarithmic functions. And so two objectives here. We're going to graph logarithmic functions first. Objective 4, graphing logarithmic functions. So first thing up here, just to review, we've talked about this a little already, that logarithmic functions, here, the pink color, is going to be the inverse of exponential functions, right? So we're going to switch the x and the y's. Negative 1 over 1 comma a becomes 1 comma a, negative 1. 0 comma 1 becomes 1 comma 0. All right? So this would be an exponential function where we had a negative x, right? We're coming down, right? And so if we flipped it, we would be looking like that for the logarithmic one. And same thing over here. The one where we're taking off flips to the one where we're coming up and then flattening out. All right, so here's an example for 2 to the x. This turns into log base 2 of x. And then 1/3 to the x, which could also be written as 3 to the negative x. And then we would have down here log 1/3 of x, or we could also have log 3 of negative x. Either one will work. All right, so just a reminder here, the domain of your parent function for logarithms is all positive real numbers. X is greater than 0. The x-intercept is 1. Remember, we're going to always cross at 1 comma 0 for our logarithmic functions. All right, x equals 0 is our vertical asymptote. X equals 0. And a logarithmic function is decreasing if a is between 0 and 1. So that's the a to the negative x. We're going to be coming down like that. And if a is bigger than 1, then we're going to be taking off like that. All right? Your parent function always has these 3 points, 1 comma 0, a1, and 1 over a, comma negative 1. Last thing, we are smooth and continuous, no bumps, no breaks, no corners, no gaps when you're drawing them. All right, so there's your natural log. Same thing here with some values. You can plug that in your calculator to check it. But here we go again, 2.718, 2.72, and we would switch the values x and y to find the logarithm of it. All right, so let's try some problems here. Let's find the domain of the logarithmic functions 3 natural log of x minus 1. All right, so we know a few things about this before we even put in our graphing calculator. We know that this is going to have an asymptote here at positive 1 because of what's going on in here. All right, so when we graph these, similar to what we did for our exponential functions, first find the asymptote, done that. Now we're going to go back to our t-table. And remember for the exponential that we found 2 good points. We're going to do the same thing here. I think it's helpful to rewrite your problem and find the exponential function. All right? So if we rewrote this, this is y equals 3 log base e of x minus 1. Run out of space here. Okay, let's divide by 3 first. Y over 3 equals log base e, natural log of x minus 1. Rewrite that. This is e to the y over 3 equals x minus 1. All right? And so for your problem here, we're going to pick some y numbers. All right? So a good y number to pick would be 0, because now we have e to the 0 over 3. Okay? And so let's actually move this 1 over. Plus 1 equals x. So e to the 0 over 3 just turns into 1. 1 plus 1 is 2. So 2 comma 0 is on your graph. And what's another good one to pick? 3 would be a great one to pick here, because then we'd have e to the 3 over 3, which is just e. 2.718 plus 1 is going to be 3.718, 3.72. Okay, so there's 3, 1, 2, 3, almost to 4 up there. And we've got ourselves a nice logarithmic graph. All right, so we've graphed it. From the graph, determine the range. The range is going to be all real. Let's find the vertical asymptote of f. X equals 1. let's find the inverse of this. All right, so we know how to do this. We have y equals, sorry, we already have y over 3 equals log e of x minus 1, right, which we rearranged as e to the y over 3, and we had plus 1 equals x, right? We've already done this work. To find the inverse, what do? We switch the x and the y. So this makes most of our work is already done. E to the x plus 3, x over 3 plus 1 equals y, right? And so then we've got the exponential graph. All right, use the inverse to confirm the range found in the range of f that we found here. All right, so the domain of this is going to be all real because it's an exponential graph. All right, and then find the range of the inverse. So that's kind of a repetitive question. All they're saying is they're opposites of each other. All right, we can finish this up by graphing the inverse. So let's go ahead and remember that we would have a horizontal asymptote at 1. Okay, and then let's pick some good numbers, x and y. Guess what our numbers are going to be? They're just the flip of these ones over here. So we're going to have 0, 2, and we're going to have 3. Put those numbers in for you. 0, 2, and 3, 3.72. So x is 3, 1, 2, 3, and 3.72 on the y. There we go. I think I put this one in wrong, didn't I? Yep. Should be 3.72, comma 3, which would be right there. Oh, the red pen doesn't want to work. Come back. There we go. So 3.72, comma 3. Sorry about that. Our graph would be a little more bent. All right. If this is confusing at all, we'll do this in the warm-up again. But just the key on this is to graph. Follow the same steps as we did for the exponential functions. Find your asymptote. Find 2 good points. All right, skip that. Let's try one more of these. So let's go backwards here and see if we can find the function first, and then we'll come to other points. So y equals negative 2 log base 10, if it doesn't say anything, x plus 2. All right, so let's go ahead and rewrite this so it's not logarithmic anymore. So we're going to divide by negative 2. Equals log base 10 of x plus 2. All right, rewrite this. This is 10 to the negative y over 2 equals x plus 2. And then 10 to the negative y over 2 minus 2 equals x. Let's go ahead and make our table. Let's pick 2 really good points for y. I like 0. 10 to the 0 is going to be 1. 1 minus 2 is negative 1. And then we should also pick negative 2. Negative 2 divided by, negative 2 divided by 2 is 1. 10 to the first power is 10. 10 minus 2 is 8. What's our asymptote? Our asymptote is going to be negative 2. From in here, it's the opposite. And what are our points? Negative 1 comma 0. And 8. 1, 2, 3, 4, 5, 6, 7, 8. Negative 2. And note here we're coming in, going down. It's a flip. And that flip happened because of this negative out front. All right. So what would our inverse be? We've got x equals, actually I'm just going to go straight to the flip. From here, switch your x and your y's. The inverse would be y equals 10 to the negative x over 2 minus 2. All right, so we could go ahead and graph that as well. For the time being, try 79. Okay, and we actually skipped one, 71. Try those two problems, 71 and 79. All right, so after graphing, we're going to come back and solve logarithmic equations. And we're going to try to solve for x. So what you're going to want to do here is rewrite 2 to the third power equals 2x plus 1. And from here, I think you can bring it home. 8 equals 2x plus 1. 7 equals 2x. 3.5, or 7 over 2 equals x. Let's solve this one. X cubed equals 343. And we're going to cube root both sides. So 343 cube rooted. And the answer there is 7. All right. Let's solve this one. Okay, so in this problem here, we started with logs and we changed them to exponents to figure them out. In a problem like this, where the x is in the exponent, we're going to need to use logs to help us out. So we've got e to the 3x equals 3, divided both sides by 2. Now, how could I possibly rewrite this so that we have a natural log? It's the natural log, right? Log base e, right? This is our base. So natural log of 3 equals 3x. And we can go ahead and solve this using our calculator. So, where's our calculator? There we go. So, plug in natural log of 3. We're going to divide by 3. And there you go, 0.367. Sorry, 0.366. Try problem 87 and 99. Okay, last one here. We're going to dive into the word problem. And so the blood alcohol concentration, the BAC, the legal limit is 0.08. That's the amount of alcohol in a person's bloodstream. If you're at 0.04%, that means you have 4 parts of alcohol per 10,000 parts of blood. Relative risk is defined as the likelihood of one event occurring divided by the likelihood of a second event occurring. For example, if an individual with a BAC of 0.02% is 1.4 times as likely to have a car accident as an individual who has not been drinking, a BAC of 0, the relative risk of an accident with a BAC of 0.02% is 1.4. All right? Recent medical research suggests that the relative risk R of having an accident while driving a car can be modeled by this equation. Okay? All right, so we don't have much space here. I'm going to go to the next slide and write that down. R equals e to the kx. And we're going to solve some problems based on that. All right, so first one, x is the percent of concentration of alcohol. Research indicates that the relative risk of a person having an accident with a BAC of 0.02 is 1.4. So, the relative risk was 1.4. 0.02 was our blood alcohol content. Let's go ahead and solve. So, we need to get k down from there. So let's rewrite this using a logarithm. So this is log base e, which is natural log of 1.4 equals 0.02 k. Go into your calculator to solve. So we've got natural log of 1.4 divided by 0.02. And now we know that k is 16.82. So we'll put that in here. K is 16.82. Let's go back here. Problem part B. Using this value of k, what's the relative risk as the concentration is 0.17? All right, so now we're solving for the relative risk. If we have 0.17 of our 16.82, this is pretty straightforward. We're just going to plug it straight into E. Graphing calculator. E to the 16.82, and you want to go up and grab it. You don't want to just plug in 0.82 because you're going to lose accuracy, times 0.17, and we get 17.46. So obviously a much higher risk if you have a much higher blood alcohol content. 0.17 would be twice the legal limit. Part C, using the same value of k, what's the BAC that corresponds to a relative risk of 100? Okay, so now we're going to change R. We're going to say R is 100 equals e to the, don't know what x is, 16.82. So natural log of 100 is 16.82x. So back to our calculator we go. Natural log of 100 divided by 16.82. And we get 0.27. That is an extremely high blood alcohol content. You might not be alive if your blood alcohol content is that high. And last one, if the law asserts that anyone with a relative risk of 5 or more should not have driving privileges, at what concentration should we arrest the person and charge them with the DUI? So trying to find for the relative risk of 5. So again, on this one, we're saying R is 5, e to the x 16.82, and so same type of problem. Natural log of 5 is 16.82x, and go ahead and plug that in. Natural log of 5 divided by 16.82, and we have a blood alcohol content of 0.095665. That's slightly higher than the current legal limit. So the legal limit is slightly higher than a relative risk of 5, or slightly lower, sorry. All right, so last thing, you can pause the video and get this down. This is just a nice little summary, but that will do it. Questions, we'll go over them in class tomorrow. Good luck.